Hello. Is it audible right now? Hello. 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 Is it audible?
Yes, sir.
Yes, ma'am. Yes, sir. Last class we were discussing alkanes, right? So alkanes we discussed alkenes started. Right now. So put the heading alkenes. Alkenes. Alkene, right? So general formula CnH2n. CnH2n. CH2 double bond CH2. What is this name? C2 H4 ethene. Ethene. So eth means what? Root word. Root word. Ene means primary suffix. Primary suffix. So like root word, primary suffix, secondary suffix we are using, right? Ene. Alkene, right? Like olefins. Alkenes we could say olefins, like oily like substance. Oily like substance. So no, we know the nomenclature part, right? No? Write the nomenclature. Come on, write the names. Right. So what is this name? right? Propene. In this case, no, 1, 2, 3, 4. Yeah. First, this is substituent. Substituent is secondary prefix, right? 2-methyl, 2-methyl, but, 2-ene. So 1, 3, 1-ene, sorry. Next here is but 1, 3 diene. But 1, 3 diene. In this case, 1, 2, 3, 4, 5, 6. X 1, 3, 5 triene, right? Then next, come on, do this. Copy JEE. First one, no? So double bond we need to start from here, right? One numbering 1, 2, 3, 4, 5, 6. X 1, 4 diene. X 1, 4 diene. Here we'll start the numbering from here. 3-methyl, X1ene, X1ene. So what about this one? Last one? Okay. Four methyl hept 1ene, 4 methyl hept 1ene. Meghna, write it down. అర్థమవుతున్నాయా? Then come on, write it down. Tetraene. So how many number of double bonds doesn't matter. So diene, triene, tetraene, pentaene, hexaene, like that we have to write. Then no. Whenever the CC single bond, I told you, free rotation is possible. Free rotation is possible. The conformational isomers we discussed in the where and alkanes. But whereas in case of alkenes, right, double bond cases. So which hybridization this carbon? This carbon which hybridization? sp2. This carbon? sp2. sp2. So how many of you know hybridization here? How to write the hybridization? For example, we'll discuss CH3, CH3, CH2, double bond CH2. Now carbon. Carbon atomic number is how much, no? 6. 1s2, 2s2, 2p2. So 2s2, 2p2, like this. This is ground state electronic configuration. Which state? Ground state. In excited state, what exactly happens? One of the electron is jumping to 2s to 2p. So 1, 2, 3, 4. Now this carbon undergoes which hybridization? The 4 single bonds are there, right? sp3. In hybridization, orbitals are participating, not the electrons. So write that point. In hybridization, orbitals are atomic orbitals are participating. One s orbital, 3 p orbitals. 3 p orbitals means total how many orbitals will get? 4. Only orbitals are participating. Atomic orbitals are participating, but not the electrons. So one s orbital, 3 p orbital, total will get new 4 orbitals. So each contains sp3, sp3 like that now. sp3, 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 sp3. Okay. So here is carbon undergoes sp3. So alkene we will do it after this. Here, one sp3 carbon, one more carbon. So this bond, this pairing of electrons is sp3, sp3. So this is carbon, this is also carbon. Carbon, carbon. Now the carbon-carbon single bond is forming because of hybrid orbitals. This is sp3, sp3 linkage. And now how many hydrogens are there here, Nana? Yeah. So hydrogen, hydrogen, hydrogen. There is also one more hydrogen, hydrogen, hydrogen. This is the structure. Sometimes they'll ask the simple questions. In ethane, how many pure orbitals and how many hybrid orbitals are present? The ratio of pure orbitals, hybrid orbitals in ethane, they'll ask the question. So it's easy, but a lot of people will do the mistakes. Right? How many hybrid orbitals and how many pure orbitals? What are pure orbitals? The orbitals which are not participating in the resonance. Which orbitals are not participating? The hydrogen. S orbital is not participating. Carbon is participating in the resonance. Right? 1, 2, 3, 4, 5, 6 pure orbitals. 1, 2, 3. So this is sp3, sp3, right? So hybrid orbitals, so these are hybrid orbitals. 1, 2, 3, 4, 5, 6 like that. So we need to say. This is about alkane. So now I'll discuss alkene. Write it down this. Total orbitals. These are hybrid orbital, hybrid, hybrid, hybrid. sp3, sp3. So which is participating in hybrid, hybrid after mixing of intermixing of atomic orbitals. This hydrogen is came purely. It is not participating. Hydrogen is only one electron, that is 1s1. 1s1. 1s1, 1s orbital is directly coming in it. Megana rai fast ga. No sariga raayatla. Okay? Now we'll try the ethene. Ethene. Ethene structure is like this, right? So carbon, two carbons are there, same like that earlier case. Carbon 6, 1s2, 2s2, 2p2. Write the ground state electronic configuration. Here is 2, 1, 2. Sir, why are you not writing this? This is inner orbital. Generally, outer orbitals we need to take. This is ground state. Ground state. Excited state, what exactly happens? Excited state, one of the electron jumping to here. But here is alkenes undergoes which hybridization? sp2, right? Here is one s orbital, two p orbitals only participating. One s orbital, sp2. sp2 means what, Nana? How many are there? Total how many hybrid orbitals are getting? 3, right? 1, 2, 3. This is one carbon. So all are contains sp2, sp2, sp2. One more carbon, sp2, sp2, sp2. Right? The electrons are sharing is takes place. So then hydrogens, right? 4 hydrogens. Now one thing is remaining. What is this one thing? One p orbital is there. That p orbital, I'm just writing in a pink color. Pure p orbital, this is pure p orbital. Undergoes sidewise overlapping. Undergoes sidewise overlapping. Sidewise overlapping. Sidewise overlapping, nothing but what we will get? Double bond. So first carbon, carbon, this is sp2, sp2, and hydrogens, and when the pink bond is forming like this, double bond, right? So alkenes, this is sp2 hybridized carbon, this is also sp2 hybridized carbon. Come on, write it down. The alkene is like this one. All are in the same plane. Whatever the groups which are present in the same plane, it is having the plane of symmetry. So this is one is sigma bond, one pi bond. In these two cases, one is sigma bond, one is pi bond. Sigma bond, pi bond, which one you can easily break? Pi bond. Pi bond is weak, sigma bond is strong. Write it down. Sigma bond, pi bond is weak. Whenever if you are breaking the bond, first we will break the pi bond. How we will get the pi bond? Right? Sidewise overlapping of p orbitals. Sidewise overlapping of p orbitals. Write that point. Sidewise overlapping of p orbitals. Sidewise overlapping of p orbitals. So in this case, sigma bond is forming because of sp2, end-end overlapping of sp2, sp2. sp2, sp2. End-end overlapping of the sp to sp2. End-end, or we could say head-on-head. Head-on-head. ఫాస్ట్ రాయలేను, మళ్ళీ నేను పేజ్ చేంజ్ చేస్తున్నాను, అక్కడే ఉండిపోతున్నాను. అది పింక్ కలర్ కనిపిస్తుందా బోర్డు పైన? Same, we can do the alkyne also, same hybridization, right? How we have to do? One s orbital, one p orbital is participating, two p orbitals are right under goes sidewise overlapping, two pi bonds are forming. Will you try? So try that. Try it. I'll explain. The people who did this, try for ethine. Done, completed. Alkyne. sp carbon, sp means 2 only. sp 2 carbons, and 2 p orbitals are there. The 2 p orbitals undergoes sidewise overlapping, we'll get 2 pi bonds. So carbon 1 CC single bond and 2 pi bonds, which I am writing with yellow color, and one is 2 hydrogens, like that. Here is 2 hydrogens, 2 hydrogens. So this is a hybrid structure. So write it down. Hybridization is one of the important, right? This carbon is sp hybridized, sp. Triple bond, when triple bond, 2 are pi bonds, right? 2 are pi bonds, one is sigma bond. Same like pi bonds are weak, we can easily break the bond because pi bonds are formed by sidewise overlapping. Sigma bond is formed by the end on end overlapping or head on head overlapping. This is also sigma bond here. This is also sigma bond. So sometimes they'll ask how many number of sigma bonds and how many number of pi bonds are present in the molecule. So they're asking the numerical type of questions. Number of sigma bonds by the ratio of number of sigma bonds and number of pi bonds. The number of sigma bonds are how many are? 1, 2, 3. 3 by 2. So 3 by 2 ratio, if they are asking 3 by 2. They are not asking the direct questions, they are asking different ways they are asking the question. So we need to ready for the any type of question. Next. Now let me know right. So first, how many types of hybridizations? Write the hybridization of carbons. Write the hybridizations of carbons. Run. Write it down. Meghna, write that. This is which hybridization? P2. If the carbon having 4 single bonds, in this case 4 single bonds are there, 3 hydrogens, 1 single bond. Yes or no? Now that case is what? sp3. If it is carbon is having 1 double bond, now that is sp2. If it is carbon is having 1 triple bond, that is sp. If carbon is having cumulative double bonds like this, sp. Okay, write it down. అర్థమైందా? ఇప్పుడు ఏంటిది ఇది? No, it doesn't have any cumulative bonds. This is having the cumulative bonds. First one, no? sp3. Second, sp2. This is sp2. This is sp. This is sp. This is sp3. This is sp2. This is sp. This is sp2. Good. Write it down. So nowadays these are the actually easy concepts, but they are not asking the directly hybridization. So how many sp bonds are there, sp2 bonds are there, how many sigma bonds are there, how many pi bonds are there, the ratio of sigma and pi bonds, that number is multiplied with 5, what is the number? Answer. The number of pi bonds, ratio, number of sigma bonds, will get some x number into 5. So they are asking you, do you know multiplication of pi table or not? sp3, sp2 and sp. What in sp3 now? What is s percentage and p percentage? In sp3 percentage of s character now. percent of s character, total 1 s orbital, 3 p orbitals, total 4. So percentage of 1 by 4 into 100, 25%. Percentage of p, 1 by 3 by 4 into 100, 75%. So write one more important point. So this is very, very important. Percentage of s character is directly proportional to electronegativity. Percentage of s character is directly proportional to electronegativity. Write it down. Done? Now do the same way for sp2 and sp. Same calculation for s and p. Same. Do it. Yeah, just do it. Write it down. Put on the paper. ఈఎన్ అంటే ఈఎన్ కాదు, ఎలక్ట్రోనెగటివిటీ. ఇస్తా ఈఎన్ కాదు. ఇషా అర్థమవుతుందా? డౌట్ ఉంటే అడుగు. Yeah, sp2, here is 1 s orbital, 2 p orbitals, total 3. Percentage of s is equals to 1 by 3 into 100. I'll get 33.33%. Percentage of p character 2 by 3, sorry, 2 by 3 into 100, 66.666 something percent. sp 1 plus 1 2, percentage of s character is equals to 1 by 2 into 100, 50%. Percentage of p is equals to 1 by 2 into 100, 50%, right? Percentage of s character greater in sp, then sp2, then sp3. So that's the reason carbon, if it is having the triple bond, this is sp, so more electronegative because percentage of character is more. This hydrogen is having which nature, nano? Acidic nature. Write it down. But not C double bond H. This is not acidic hydrogen. Right? This hydrogen is not acidic hydrogen. Only C triple bond C carbon. Hydrogen is acidic hydrogen, very important. Right. So slow now, బాగా నేను పేజ్ చెప్పేస్తున్నాను, సగం మళ్ళీ పేజ్ అయిపోతుంది. ఫాస్ట్గా ఉండాలి. నేను రాసేటప్పుడు నాతో పాటు ఫాస్ట్గా రాయాలి, తర్వాత అడగాలి. In case of inorganic cases, hybridization, how should we have to find inorganic cases? Huh? Hello? BeCl2, BeCl3, so BeCl2, right? BeCl3, CH4, SiCl4, BeCl3, BeCl5, SF6, IF7, I3 minus, H2O, H3O plus, NH3, NH4 plus, XeF2, XeF4, XeF6, XeO2F2, XeO4, SO4 2 minus. 20 questions which I gave you. So will you do that homework? Hybridization. Homework. Hybridization and structure. Hybridization and structure. Isha, will you do, or shall I explain or some one or two? Yes. Uh, First copy the questions. You also. So I'll tell without using any formula. What is its hybridization and its structures? So this is one of the important and compulsory question in any exam, in NEET, in BITSAT. Huh? 20 only? 14 మిస్ అయిందా? 13 తర్వాత 14 ఎక్కడికి పోయింది? రాద్దాం 14. Akshita, will you do this? नहीं होमवर्क नहीं, आप कर सकते, पूछ रहा हूँ. नहीं कॉन्सेप्ट नहीं तो मैं बताता हूँ. हाँ आई टॉट बट याद है ना नहीं? नहीं जब भी देते तो वही वैसे करना ये that much of important anytime. So what is your name? Will you revise and will tell, or that much of important? So someone if what is your name means okay, I'll ask my parents and I'll let you know. फिलहाल तो मैं रिवाइज किया नहीं मेरा नाम. Right. So to solve this type of questions, first we need to know, right, periodic table S and P block elements. Right, first A group elements now, first A, right, hydrogen, of course, then lithium, sodium, potassium, rubidium, cesium, francium. Write it down. Second A group elements, beryllium, magnesium, calcium, strontium, barium, radium. Right. Third A group elements, third A, boron, aluminium, gallium, indium, thallium. Fourth A group elements, what nana? Carbon, silicon, germanium, tin, lead. Fifth A group elements, nitrogen, phosphorus, arsenic, antimony, bismuth. Next, sixth A group elements, sixth A group, oxygen, sulfur, selenium, tellurium, polonium. Next, seventh A, fluorine, chlorine, bromine, iodine, astatine. And zero group or eighth group elements, zero group or eighth, helium, neon, argon, krypton, xenon, radon. Yesterday one question, means 28th they asked one question. This is first period, second, third, fourth, fifth, sixth, seventh. So left to right when we are moving, the size is decreases up to halogens. No? So this noble gas is somewhat higher. So they asked the question potassium, they gave in the option potassium and bromine. So this size is larger, this size is small. and different combinations they asked. So this is the answer, right? Simple questions also they are asking. We cannot predict where they are asking the questions. Earlier I won't teach all these things. Hybridization means like sigma bond. A lot of people nowadays, they don't know what is sigma bond, what is pi bond, which is weaker, which is stronger, how it is forming, right? Everything, which hybridization it is. A lot of people are, right, VIPs. They don't remember all the things. So now, whatever I gave you the 20 questions. So first, we need to identify its central atom. Central atom, Akshita, Isha. Central atom. For example, water is there. Isha, Isha. In water, what is central atom? Like this, right? We'll write so this is central oxygen. Oxygen belongs to which group? Sixth. So means 6 number, just you need to remember. 6 number. 6 valency electrons are there with the. So group number is nothing but valence, number of valency electrons. Okay. Is it clear first thing? So now we'll do water. H2O is given. Oxygen. Oxygen is a central atom. So now oxygen belongs to 6th A group, means 6 electrons, right? Like this 1, 2, 3, 4, 5, 6 electrons. 2 hydrogens are there, right? Each hydrogen will take one electron. This is 1 electron, this is 1 electron. Lone pair, lone pair. So total give the numbering like this: 1 bond, 2 bond, and lone pair is also 1, like this 1, 2, 3, 4. 1, 2, 3, 4. Yes or no? So here is, write it down. If 2 number is coming always, that is this number we are called as steric number. If 2 number is coming, that is SP. Okay now? If 3 number is coming, SP2. 4 number is coming, SP3. 5 number is coming, SP3D. 6 number is coming, SP3D2. 7 number is coming, SP3D3. So steric number. Now 4 number. 4 number means which not? Which one now? Hello. Isha. SP3, right? SP3, which contains how many lone pairs? How many lone pairs? Lone pair means this is which are not participating in the bonding. 2 lone pairs. SP3 with 2 lone pairs. SP3 with 2 lone pairs. Okay. Now we'll do one more question. Is it clear? So here is one more important thing, right? SP3 is generally tetrahedral shape, but here is whenever the lone pairs are coming, the shape is changing. So what is this shape? Hello. Right now, SP3 means tetrahedral shape. Tetrahedral shape. All are in the 4 different directions. So tetrahedral, I'll show you. So this is tetrahedral shape. So tetrahedral means like this. Got it? Hello. So this is this direction. This is this. This is this. This is up. For example, like this. Tetrahedral shape. sp3. Now, if it is having one lone pair, imagine this is lone pair. Now they are coming trigonal planar shape. They are coming in the same plane. sp3 with one lone pair. Trigonal pyramidal. This is pyramidal, trigonal pyramidal like this. Only pyramidal. H2O is V shape or bent shape. H2O is H2O is like this, water bent shape, V shape or bent shape. sp3 with two lone pairs, right? V shape or bent shape. Okay, hello. For sp3 cases, we need to know these three. Done? For example, H3O plus ra. H3O plus. If plus charge is coming, plus means we need to remove one electron. Actually, now what is the central atom, Isha? Oxygen. 6. 1, 2, 3, 4, 5, 6. But whenever the plus is there, so what we need to do? We remove one. So now, hello. 1, 2, 3, 4, 5. 3 hydrogens. 1, 2, 3. And one lone pair. 1, 2, 3, 4. 4 means what? sp3. sp3 with one lone pair. Trigonal pyramidal shape. Got it? Hello. So anything if you want, Amma Rasko. For example, any other example you want? Anybody wants in the 20? Let me know, I'll explain. NH3. Isha, tell me you only. Yeah. How many? Which group? No. Central atom. Go back and see, sir. You should know, sir. That is the fundamental, sir. Nitrogen, sir. Didn't you write? Yeah. Cross check. Group 15 or 5th? 5th A or 15th. Both are correct. But A wala, right? A wala 5th means 5 electrons, right? 1, 2, 3, 4, 5. 1, 2, 3. 1. 1, 2, 3, 4. 4. sp3 with one lone pair. Trigonal pyramidal. समझ में आ रहा ना? नाइट्रोजन लोन पेयर हाइड्रोजन हाइड्रोजन हाइड्रोजन. For example, NH4 plus. NH4 plus. Tell me how we have to do. So 4 only we have to take, right? 5 actually, but plus means we need to remove 1, right? So 4 hydrogens, 4. 1 2 3 4. 1 2 3 4. 4 मतलब sp3 0 lone pairs tetrahedral. Tetrahedral. Right. राई मतलब पत्थर भी बोलते राई. तेलुगु में राई है तो पढ़ो लिखो और बोलते थे, पत्थर भी बोलते थे. डन. Hello. But one exception is there, no? In case of oxygens, for example, XeO2F2, for example, this is a molecule. So what is the central atom here? Xe. Xe means 8th group. 1 2 3 4 5 6 7 8. Right, each oxygen we need to take 2 electrons. That only the thing you need to take care. For fluorine is only one lone pair. 1 2 3 4 5. 5 मतलब sp3d. So write one more important. This lot of people are confusing in this particular case. sp3 sp3d without 0 lone pairs, no? Trigonal pyramidal shape. Trigonal pyramidal shape means 3 are in the trigonal and एक bipyramidal, एक down, एक x like this. Trigonal like this. Trigonal bipyramidal. sp3d with one lone pair. sp3d with one lone pair. This is here called as seesaw shape. And one more important thing, sp3d with 2 lone pairs. This is, we could say, T shape. T is sleeping, right? T shape. So simply we need to remember like this, seesaw T. So glass lo chai untadi kada, tea untadi kada, seesaw lo tea, right? Seesaw tea. So any other examples? Isha now are able to do those remaining questions? Sure. Or if you have any doubt, let me know. And one more, that sp3d2 octahedral shape, and sp3d2 with one lone pair, square pyramidal, sp3 with d2 with two lone pairs, square planar. 4 structures, 3 completed on that. sp3 d2 with 0 lone pairs, octahedral. Octahedral means what? 4 are in the right, like this. X are in the same plane, so one is above and one is below. One is above and one is below. This is octahedral shape. If sp3 d2 with one lone pair, right, square pyramidal. So the same model, x 1 x, so down one can take the lone pair. sp3 d2 with two lone pairs, square planar, all are in the same plane. So the two lone pairs, one is above and one is below, square planar. Write it down. After learning this, so we need to know the bond angles also. If you know the structures, bond angles are very easy. So in case of here, all are 90 degree. All are 90 degrees. So I'll let you know that. First, what about sp3d3 structure? sp3d3, pentagonal bipyramidal, right? One is above, one is below, pentagonal bipyramidal. Pentagonal bipyramidal. Well, I was supposed to do alkenes today. No need, actually. That I explained for that organic case. This is inorganic chemical bonding. This is also very important. People are Gajnis. That's the reason I have to explain once again, because important, right? This is Gajini. You didn't see the Gajini movie? We'll write total body, year. Today alkanes, right? ఇక్కడ చేతులకి ఇక్కడ వస్తుంది. షార్ట్ టర్మ్ మెమరీ లాస్. After 10 minutes you don't remember anything. Short term 10 minutes only, right? So one thing I didn't explain, that is sp2. sp2 trigonal planar shape. Trigonal planar. sp2 trigonal planar. sp2 with one lone pair. sp2 with one lone pair. V shape or bend shape now. V shape or vent shape? Come on. sp2, alkenes sp2. sp sp. Hello. Linear, straight. sp linear. Write it down. నేను నాతో చెప్పించుకోదు, నేను నెక్స్ట్ టైం నుంచి నువ్వే రాసేసాలి ఫాస్ట్గా, నాకంటే ముందు రాసేసిన సార్ అని చెప్పాలి. నువ్వు అందరికంటే ముందు రాస్తే నీకు చాక్లెట్ ఇస్తా. బస్ ఇవాళ వద్దా? తింటావా చాక్లెట్? నో, దగ్గర లేవైనా. డనా? హలో. Isha, would you try this PCL file? SF6 you try. Meghna, SF6. Akshita, you need to try XCF4. I3 minus. Amsini. Nikki. PCL3. PH4. Sona. A question is cheyali ippudu. A question ichana ek నేను hybridization structure. Sulfur which group? Sulfur which group? You didn't write the periodic table. Yes. Good. SF6, huh? XCF4. Two lone pairs. Okay. Meghna, 6. Good. Six తీసుకో నువ్వు. హలో, 6. Sulfur which group number? Oxygen, sulfur. 6 valence electrons, right? 6 intos. So how many fluorines are there? 6. Write it down. Right, 6 Fs. డాష్ ఎఫ్ డాష్ ఎఫ్. నువ్వు ఇంతకుముందు చూసినావు కదా ఇక్కడ అక్కడెక్కడ ఎలా చేశాను నేను? చేస్తాను కదా డాష్ డాష్ ఎఫ్ ప్లస్లో హెచ్ ప్లస్లో ఎఫ్ పెట్టు. అర్థం కాలే. ఇట్లా చేసినట్టుగా ఇవన్నీ చేసినట్టుగానే ఇది కూడా చేయాలి. ఎస్ ఫస్ట్ ఏ గ్రూప్, సెకండ్ థర్డ్ ఏ, ఎయిత్ గ్రూప్. సోడియం, పొటాషియం, రుబీడియం, ఈజియం, ఫ్రాన్షియం ఇవి వస్తాయా? బెరీలియం, కాల్షియం, ఫ్రాన్షియం, బేరియం, బోరాన్, అల్యూమినియం ఇవి. కార్బన్, థాలియం, కార్బన్, సిలికాన్, జర్మేనియం, టిన్, lead, right? Nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, chlorine, chlorine, astatine, helium, neon, astatine, and argon, krypton. The sulfur is A group, sixth A group. 6 కాబట్టి SF6. 1 2 3 4 5 6 6 fluorines, right? 1 2 3 4 5 6 6 means sp3d2. sp3d2 means what? Octahedral shape. Octahedral shape. No, plus the fifth plus S is 1, right? 1 plus 3 plus 2. Periodic number ఎక్కడ రాసాను? రాయలే. సగం రాస్తున్నావు, సగం రాస్తలేదు. అందుకోసం రాయలేకపోతే 2 అయితే 3 అయితే 4 అయితే 5 అయితే 6 అయితే ఇవి రాసుకోవాలి కదా మరి. మంచి రాస్తున్నావు, నీట్గా రాసినంత వరకు బాగానే రాస్తున్నావు, కానీ అన్నీ రాయట్లే. ఫాస్ట్ నాతో పాటు ఫాస్ట్గా రాయడం నేర్చుకో. రా I3 మైనస్ ఎట్లా చేస్తావు? I center, 2 I's are like this, minus 7 plus 1 8. 1 2 3 4 5 6 7 8. I 1 2 3 1 2 3 4 5. sp3d, sp3d with 3 lone pairs, linear association. Hmm. Right. So tomorrow I'll do so revise geometrical isomerism and counting of geometrical isomers with formulas. Tomorrow I'll directly start the preparation of alkenes, physical properties and chemical properties tomorrow. Okay, na?